Okay, let's begin the lecture. I'll put the link in the group. Okay, so we'll begin the lecture now. After the students join in, so let me wait for some time, for 5 minutes, and then I'll begin the lecture. So I just posted the link in the group. So I'm waiting for some students to join here. Okay, now can you hear me? Okay, I'll begin the lecture now. So this is the third lecture. So in the first lecture we covered basics concerning trigonometry and coordinate geometry. We looked at some trigonometric identities. We looked at the relationships between trigonometric ratios. We also looked at compound angles. We looked at the expressions of sine 2 theta, cos 2 theta, and all the relationships relating to those trigonometric ratios. We have also seen that when theta is small, sine theta equals tan theta equals to theta. Okay, anyway, now I would like to just go through a couple of things in coordinate geometry, and then I'll proceed to calculus. So calculus is very important for approaching any chapter in physics, except for few chapters in modern physics and geometric optics. So this lecture is quite important, and the depth of understanding of this lecture will decide how well you are going to go through rest of the physics. So first thing we discussed about was about slope. Slope of any line was given by m. M was equal to change in y by change in x. Correct? Slope was equal to change in the value of y by change in the value of x. When you had a Cartesian plane in which horizontal axis was x-axis and vertical axis was y-axis, and if you move from one point to the other point, point A to point B, both the values of x as well as y change. So this is x1, this is y1, this is x2, and this is represented by the ordered pair of x1 comma y1 by another ordered pair of x2 x2 comma y2. So when you move from point A to point B, the values of x as well as y may change. Okay, so what is the slope of this line? The slope of this line is given as m equals to change in the value of y by change in the value of x, which is nothing but y2 minus y1. It is the change in the value of y, because this is the change in the value of y, y2 minus y1, because this is y2 and this is y1. So the distance between y2 and y1 is delta y. So this is your delta y, and by delta x, which is change in the value of x. So this is the change in the value of x that corresponds to this. So this is x2 minus x1. So this was the slope, right? Now, one more thing we learned about slope was this. So if you have a Cartesian plane again, so just let me increase the, okay. If you have a Cartesian plane like this, if you had any straight line, if you had any straight line, okay, this is a little bit more, so let it be here. Okay, if you have any straight line like this, okay, if you have any straight line, now what was the fact about straight lines or linear equations? The fact about straight lines and linear equations is that their slope is constant everywhere. Their slope is constant everywhere. No matter where you stand, the slope will be same. Slope will be same here, slope will be same here, slope will be same everywhere. Now, I told you that angle of any line is always measured from positive x-axis in anti-clockwise direction. So this is the angle of this line. And you also know that slope is change in y by change in x. Suppose you start from here and you reach this point. This is the change in value of y. This is the change in value of x. This is the change in value of x. So what was your slope? What was your slope? Your slope was m, which was equal to change in value of y by change in value of x, which is also equal to tan theta. Why? Because delta y is opposite side and delta x is adjacent side. So it is also equal to tan theta, because in any right angle triangle, this is your right angle triangle, in any right angle triangle, the ratio of opposite side to adjacent side is defined as tan theta. Okay, so the opposite side to theta is delta y here, and the adjacent side is delta x. So slope can also be given by tan theta, where theta is the angle that the line makes, with x-axis. Clear? Now next thing is this. Suppose we have a line which doesn't make an acute angle, which makes an obtuse angle, So if you have a line like this, okay, now if you measure the angle of this line, this angle is obtuse. Okay, it is not acute, it is greater than 90 degrees. You start from positive x-axis and go in anti-clockwise direction. So this angle is obtuse. So what will be tan theta? Tell me, what will be tan theta? Tan theta will be negative. It is again delta y by delta x. So what is delta y here? You started at this point, okay, and you moved to some point here, okay. So you are starting here and you are moving along the line. You started at point A and you were moving at point B. Now look what is happening. When you are going from point A to point B, change in y is positive. Change in y is positive because y is increasing. Whereas change in x, see, change in y is positive because y is, initial y is 0 and final y is some positive value. But when you are going from A to B, the value of x is negative because you are starting at some positive point and you are ending up at 0. So change in x is negative. So what is positive by negative? Positive by negative is negative. So the slope of this line is negative. The slope of this line is negative. Another way of looking at this is, see. Another way of looking at this is, suppose you have a line like this. You start here and you end here. You are going from point A to point B. See, when you are going from point A to point B, value of x is increasing. That means delta x is positive, and value of y is also increasing. So delta y is also positive. So slope which is given by delta y by delta x is also positive. You know why? Because positive by positive is positive. Correct? And this also makes an acute angle. This also makes an acute angle with what? Horizontal, what positive? X-axis. So tan theta is also positive. Tan theta is also positive. We have seen that in first quadrant, whenever angles lie between 0 and 90 degrees, tan is positive. All are positive. Sin is positive, cos is positive, and tan is positive. Clear? Next. Whenever you have a line like this, okay, so you start at one point and you move to second point, from point A to point B. What is happening? Change in y is positive. See, change in y is delta y is positive. Change in x, when you come from A to B, change in x is what? Change in x is negative. Change in y is positive and change in x is negative. So what is slope? Delta y by delta x. Now this was negative, this was positive, okay? And this was negative. What is positive by negative? Negative. Therefore slope is also negative here. And what about angle? If you look at angle that this line makes with positive x-axis, that angle is what? Obtuse. That means it will lie between 90 and 180. So what is tan theta? Tan theta is also negative. You know why? Why tan theta is negative? Because in second quadrant only sin is positive, tan is negative. Clear? So any line if you draw, any line if you draw in Cartesian plane, if you draw any line, it will either make obtuse angle or it will make acute angle. Correct? So slopes of all these kinds of lines, if the lines are like this, the slopes of all these lines are positive because all these lines make acute angle with x-axis. Slope of all these lines, okay, slope of all these lines is negative because all these lines make obtuse angle with positive x-axis in anti-clockwise direction. And if the line is vertical, then slope is 0. Why? Because they lie between positive and negative slope lines. So the slope is 0. Clear? So any vertical line has slope 0. Any line that makes acute angle with x-axis has slope positive. Any line that makes obtuse angle with x-axis has slope of has a negative slope. Okay, fine. Till here it's fine. Second thing, I told you one thing, and most of you may remember it from school that if two lines are perpendicular, the products of their slopes is -1. The products of their slopes is -1. If two lines are perpendicular, the products of their slopes is -1. That means if you have two lines, first line has slope m1, second line has slope m2, then if they are perpendicular, m1 times m2 should be equal to -1. So this is one fact. Now why is this true? Let us try to see. Okay. Now one more thing, just before going into this, I'm just giving you a quick revision of what I just said. Any line that makes acute angle has positive slope. Any line that makes obtuse angle has negative slope. Any line that is perpendicular has slope equals to 0, and any line which is horizontal has any line that makes any line that is horizontal has slope 0, and any line that is vertical has slope of infinity. Any line that has slope that is vertical has slope of infinity. Okay, why? Because tan 90 is what? Infinity, or I should say actually it is undefined. It is undefined, not infinity, because it may be plus infinity or minus infinity depending on where the line is tilted. It is undefined. Okay, let me just make it clear once again. Let me generalize what I just said. So what I told was, see, any line that makes acute angle has positive slope. Any line that makes obtuse angle has negative slope. Any horizontal line has slope 0, and any vertical line has slope that is undefined. Why it is undefined? I'll just tell why it is undefined. Why? Because, see, if you have this Cartesian plane, and if you have line that is just tilted like this, that means the angle is in first quadrant, then the slope of this line will approach plus infinity. Why? Because it is in the first quadrant, and tan theta in the first quadrant is in positive, so it will approach plus infinity. And as soon as it crosses that vertical line, if it just goes into the second quadrant, it will have slope of minus infinity. Okay, it will have slope of minus infinity. So what about the line that is exactly perpendicular? Is it plus infinity or minus infinity? Actually, it is neither. It lies between plus infinity and minus infinity. That means at exactly at that point we cannot define what the slope is. Exactly at that time, at that position, at that angle or at that orientation, the slope of the line is actually undefined, because it is neither plus infinity nor minus infinity. It is between plus infinity and minus infinity. That's why slope is what? Slope is undefined. Slope is undefined for a vertical line. For a horizontal line, slope is 0. For a line that makes any acute angle, slope is positive. For a line that makes obtuse angle, slope is negative. Clear? Okay. Next. Why, if two lines have slopes m1 and m2, if two lines have slopes m1 and m2, why is their product of slopes minus 1 if they are perpendicular? Why? Let us see. I told you. What did I tell you? That slopes are, suppose this is one line. Let us say that is line 1. I'll draw another line. Say that is line L2. This line has slope m1 and this line has slope m2. Correct? Now, it is clear that angle between them is 90 degrees. Okay, because they are perpendicular. Now, what is the angle that L1 makes? Let that be theta 1. What is the angle that L2 makes with positive x-axis? Let that be theta 2. Now can you see here, can you see that theta 2 minus theta 1 is 90 degrees? Theta 2 minus theta 1 is equal to 90 degrees. Do you agree? Okay. So theta 2 minus theta 1 is 90 degrees. Now I'll apply tan theta on both sides here. So tan of theta 2 minus theta 1 should be equal to tan of 90. What is tan of 90? Tan of 90 is undefined. Undefined is something by 0. Undefined is something by 0 or 1 by 0. Okay. So that means this should be equal to 1 by 0. So tan, what is tan theta 2 minus tan theta 1? It is tan theta 2 minus tan theta 1 divided by 1 plus tan theta 2 tan theta 1. Correct? Which is equal to something by 0, because tan 90 is something by 0, which is undefined. Clear? Now, what is tan theta 1? Here, what is tan theta 1? Tan theta 1 is slope of first line. Tan theta 1 is m1. And what is tan theta 2? It is slope of second line. It is m2. Do you agree? Okay. So this will become m2 minus m1 by 1 plus m1 m2 equals to 1 by 0. Now if this needs to be true, then the denominators must be equal, right? So 1 plus m1 m2 must be equal to 0, implies m1 m2 should be equal to minus 1. Therefore, if two lines are perpendicular, the product of their slope should be equal to -1. Clear? Till here, everything is clear. Now let us begin our calculus. Okay. Now, what is calculus actually? Now, till now you have seen how to calculate the slopes of straight lines. Slopes of straight lines are easy to calculate. Slopes of straight lines are easily, doable. They are very easy to find. Just take 2 points, take the values of the coordinates, and use the formula of delta y by delta x and find the slope. Okay. So delta y is y2 minus y1 and delta x is x2 minus x1, and slope is delta y by delta x. So you will get y2 minus y1 by x2 minus x1, and you can find the slope. You can take any 2 points because slope is same. But what if function is non-linear? What is the meaning of a non-linear function? What if function is non-linear? What is the meaning of a non-linear function? Let us see. Now, if this is x-axis and this is y-axis, and if you write any linear equation, if you plot any linear equation, y equals to mx plus c, what do you get? Y is equal to mx plus c, what do you get? You get a straight line, correct? If you plot some other functions, like say, if you plot some other functions, this is x-axis, this is y-axis, and if you plot a function like y equals to x squared, what do you get? Y is equal to x square, what do you get? You get a plot that is something like this. You get a plot that is something like this. You will get a parabola. Why? Because at 0, y will be 0. At x equals to 0, y will be 0. At x equals to 1, y will be equal to 1. At x equal to 2, y will be equal to 4. At 3, it will be equal to 9, and so on and so forth. At -1 also, you'll have y equal to 1, because -1 squared is 1. At x equal to -2, you'll have y is equal to 4 again, and you'll get this kind of plot. Okay, you'll get this kind of plot. You'll get this kind of plot. Okay, for y equals to x square. Now, if you look at this two equations, the first equation is a linear equation. This equation is a linear equation, and this equation is a non-linear equation. So second equation is a non-linear equation. Okay, first equation is a linear equation and second equation is a non-linear equation. Now, what is the difference between linear and non-linear equations? So when you have a linear equation, the slope is same everywhere in this straight line. When you have non-linear equation here, in this case, slope is what? Slope is different at different points. Slope is different at different points. Okay. One second. I think there is a lag. Okay, now I think, okay, fine. Now I think it is visible. Okay. So whenever you have a linear equation, the slope is same everywhere. So this is a linear equation. Slope is same at every point. Slope is same at every point. Whenever you have a non-linear equation, slope is different points. Now, if you want to find the slope of a non-linear equation, you cannot use the formula of y2 minus y1 by x2 minus x1. Why? Because slope is different at different points. Whenever you have a nonlinear equation, the second question that arises is what? Where do you need to find the slope? Where do you need to find the slope? For example, this some nonlinear equation. You have this nonlinear equation. So slope is different at different points. Slope is different at different points. So here the slope is little bit less. Here the slope is little bit more. Okay, slope is different at different points. So if he asks you what is the slope of this line, you have to ask him where do you want the slope, because the answer is not a constant. Answer is variable, because the slope is changing at different values of x. So this is one value of x, you have one slope, another value of x, you have another slope. So slope is variable here. So you have to ask the questioner that if you want to find the slope, you have to give me the point where I need to give you the slope. Otherwise, I can give you the slope, but the slope will be variable. It will be in the as a function of x again. That means the slope will change with the value of x. Clear? Slope will change with the value of x. So let us try to find what the slope is. Now watch carefully. From here, everything is very important. This is your function, which is nonlinear. Now, if you wish to find the slope of this function, at every point slope is different. So I wish to find the slope of this function at this particular point. Say that is x. Okay. So you have to take another point in the neighborhood of x, but very close to x. So here I will take another point, which is close to x. That's why the value of that point will be what? X plus dx. What is dx? Dx is change in x. Okay, dx is change in x. Change in x. Now till now we were writing delta x and delta y. Why? Because changes were big. Okay, when the changes are small, we replace delta by d. Okay, we replace delta by d. So these are very infinitesimally small changes. So small letter d for delta. In Latin, in Greek, capital D is written as delta, small d is written as d. That we, the same way we write in English. So for big change, you use delta x. For a small change, you use dx. For a big change, you use delta y. For a point, and in the neighborhood of x, I am taking another point as delta x. So this value, the length of this section will be equal to delta x. This is delta x, correct? So this point is x, this point is x, this point is x plus dx. Therefore, the distance between 2 points will be equal to dx. Distance between 2 points will be equal to dx. This will be dx. Okay. Now you have come from, okay, let me zoom in a little. Okay, let me zoom in a little. I think, yeah. So you are coming from this point to that point. Now the thing is that this, but if you consider 2 points that are very close enough, will appear almost like a straight line. That means when you look at a small section of a curve, it will almost be a straight line for you. Okay, so this can be considered as a straight line. This green section of the curve can be considered as a straight line. Now for that you can use the formula of slope. What is the formula of slope? Formula of slope is, what is the formula of slope? So formula of slope, delta y by delta x for straight lines. But here we are not moving significantly, so it will change to dy by dx. So value of slope is m equals to delta y by delta x, which is equal to dy by dx. Okay, so the slope is dy by dx. So this is dy and this is dx. But what? So if this point is x, this point will be f of x, and this point will be f of x plus dx. Correct? Do you agree? This point is f of x plus dx, and this point is f of x. F of x corresponds to x, and f of x plus dx corresponds to x plus dx. That means for any point on x-axis which is at x, the graph will be plotted corresponding to y equals to f of x. And for another point, x plus dx, the point will correspond to f of x plus dx, correct? So what is dy here according to the diagram? What is dy? What is dy? So dy is actually equal to this line, which is also equal to this line, correct? So it is f of x plus dx minus f of x. This is dy. And what is dx? So dy by dx is slope, right? So dy by dx is equal to f of x plus dx minus f of x divided by what? X plus dx minus x, correct? Because this point is x plus dx and this point is x. So delta dx will be equal to x plus dx minus x. So anyway, it is dx. So what will you get? Dy by dx equals to f of x plus dx minus f of x by dx. Okay. So this is the fundamental equation for differential calculus. So how to find the derivative of any function y is equal to f of x? You write f of x plus dx minus f of x by dx. F of x plus dx minus f of x by dx. I'll just explain it again. I'll draw a little bit bigger and I'll explain. Now here you have x-axis and y-axis. Listen carefully now. If you have x-axis and y-axis, okay, let me use different color. You have some nonlinear equation here. You wish to find the slope of this. So the thing is, slope is not constant, slope is changing, slope is variable. Okay, at some places the curve is steep and at some places it is less steep. So obviously the slope of this curve will not be constant, it will be variable. Now how to find the slope as variable? You will not get a constant quantity, you will get a function of x. Okay, that means that slope will change with x. At different points you will have different value for slope. So what I will do is I will take one point x. Okay, I'll take one point x. So for that x, you will have some y. So this is a function which is y equals to f of x, right? It can be anything. F of x can be x square, it can be sin x, it can be x cube, whatever it is. So the corresponding point will be f of x, correct? So I'll take another point in the neighborhood of x, close to x, but I am drawing little bit farther just for clean visualization. Okay, because if I'm drawing closer, it is not very easily visible in the screen, so I'm drawing a little bit far, but this point should actually be close. So I'm making an increment of dx, small increment of dx. So this is dx, correct? This line is dx. So this point will become x plus dx. So this point will become x plus dx. So this point is x and this point is x plus dx. So for that, what will be the function that corresponds to x plus dx? It will be f of x plus dx, correct? Now here if you see, you'll get this small triangle. And if these 2 points are very close, this portion of line will almost look like a straight line. That means now you can apply the formula for slope. What is formula of slope? Change in value of y, which is dy, by change in value of x. This is the formula for slope, right? So m is equal to delta y by delta x. But when delta y and delta x are small, they become dy and dx. So the value of slope will be m equals to dy by dx. So this is also called derivative of phi. So in other words, derivative is nothing but slope. So in place of phi, what you can write? You can write f of x by dx. You can write it like this also. But according to the diagram, what is this dy by dx? Let us try to see. What is dy? So let me take another color. Okay, I'll take white. So what is dy? This is dy, because this is dy, that is also dy. So what is dy? It is f of x plus dx minus f of x, correct? F of x plus dx minus f of x gives you dy. By what is dx? Dx is dx, so write dx. Or you can write x plus dx minus x, still you will get dx. So what is the formula for dy by dx? Dy by dx is f of x plus dx minus f of x by dx. Correct? So this is the formula for derivative of a function. Derivative of y equals to f of x. So what is the formula for the derivative of a function y equals to f of x? It's f of x plus dx minus f of x by dx. So what is dx here? Here dx is a small value. Small value. That means dx is something that approaches 0. It's a value like 0.00000001, something like that. So this is what the fundamental equation for differential calculus is. So basically what is derivative of a function at a point x? It's nothing but slope of the function at that point. It is nothing but slope of the function at that point. Okay. So this you have to remember always. What is derivative of the function of any function? Derivative of any function is slope of the function at that point. Okay, clear? And what is the formula for a derivative? It's dy by dx. It's represented by dy by dx. It is also represented by f dash of x. Okay, any function f of x, its derivative is either represented in this style f dash of x or f prime of x, or it is represented by this style, in this style dy by dx. So this was dy by dx was introduced by Leibniz, and f dash of x was introduced by Newton. This notation was introduced by Newton. F dash of or f prime of x was introduced by Newton, and dy by dx was introduced by Leibniz. Both of them, they say that they came out with the idea of calculus independently at the same time in history. Okay, they lived at the same time. Newton was older, he was young, Leibniz. So they also accuse each other of you know taking the ideas from the other guy, but nonetheless both are given the credit for the invention of calculus. So anyway, so this formula you have to remember, and we'll use this formula now for deriving formulas for derivatives of various functions. Okay, now let me begin by simple function. Suppose you have y equals to mx plus c. You have y equals to mx plus c. You know that this is the equation of a straight line, or this is a linear equation. You also know that slope of this line is m. Let us apply our formula of you know fundamental fundamental theorem of differential calculus, which is f of x equals to f of x plus dx minus f of x by dx, and check whether we get the slope to be m or not. Let us see. So what is f of x? This is y equals to f of x. Y equals to f of x. So what is f of x? F of x is mx plus c. So what is f of x plus dx? It will be m of x plus dx plus c, because if f of x is mx plus c, f of x plus dx will be same, but in place of x you write what? In place of x you write x plus dx. So you will get this. This is f of x plus dx. Minus f of x is what? Mx plus c. So this is f of x divided by dx. Correct? Now what will happen? Just expand it. Just expand it. So what do you get? Mx plus mdx plus c minus mx minus c by dx. So mx cancels, c cancels. What remains is m dx by dx. So dx cancels and you'll get m. So dy by dx is what? M. Now is m a constant? Yes, constant. It's a constant, right? Because it is not this value is not depending on x. That means m is a constant, and we already expected that because this is a straight line and its slope must be constant. That means it should not change with the value of x. Everywhere you go, the slope should be same, and it should be equal to m also. And we got m. Clear? Okay, so for any line y equals to mx plus c, slope is what? M. So if y equals to x, what will be the slope? It will be 1, because m is 1 here. What is dy by dx? Equal to 1, because see, f of x plus dx minus f of x by dx. Okay, so x cancels, so it is dx by dx. Dx will cancel, and your slope is 1. So for y is equal to x, your derivative is 1. And let us draw the graph of y equals to x. So this is your x-axis, this is your y-axis, this is the line y equals to x. Okay, it will make 45 degrees with x-axis, obviously, because it lies between x and y, 1 comma 1, 2 comma 2, 3 comma 3, because x equals to y, 0 comma 0, so it will make 45 degrees. And what is tan 45? Tan 45 is equal to 1. Clear? So the slope of this line is 1 in, you know, however you try to find it. You use tan 45, you are getting 1. You use the expression y equals to mx plus c, according to that m is 1. If you use fundamental theorem of calculus, which is what, f of x plus dx minus f of x by f of x plus dx minus f of x by dx, you still get 1. Clear? Next, what if f of x is non-linear, x squared? So if f of x is equal to x squared, the graph is something like this. See, graph is something like this. Now what do you observe in this graph? What do you observe in this graph? Let us just uh, do some analysis of this graph. At this point, slope is okay. At this point, at the apex of this parabola, slope is 0, because it is horizontal, right? If horizontal line is horizontal, then the slope is 0. What is happening as you are coming to the right? Slope is increasing, and it is becoming more and more positive, and it is becoming steeper and steeper. And what is happening if you are coming to the negative side? Slope is again negative. Clear? Why slope is negative? Because here if you draw tangent, it will make acute angle. Here if you draw tangent, it will make obtuse angle with positive x-axis. That's why slope is negative. All the lines like this have slope negative. All the lines like this have slope all the lines like this have slope positive. All the lines like this have slope negative. So in this graph, on the right, if you see on the right, slope is positive. That means if you move on this line here, if you move on this line from here to here, change in x is positive and change in y is also positive. So delta y by delta x is also positive by positive negative, correct? Whereas if you move on this section, okay, if you move on this section from here to here, what is happening? Okay, what is happening? Change in x is positive, but change in y is negative. Change in x is positive, but change in y is negative. So what is delta y by delta x? Negative by positive. So you will have negative slope there. Here change in x is positive, change in y is positive when you move from here to here. So slope is delta y by delta x, so slope is negative. Clear? So let me just brush you up with the slopes first before going into the derivatives. Okay, because graphically also you have to be strong. Suppose you have some graph like this. Okay, now this graph I'm writing in yellow the value of this graph is negative here, and when it crosses x-axis the value of the graph is positive. What? Value of the graph. What is value of the graph? Y is value of graph. And what is y equals to? Some function of x. So y is positive, and here y is negative. Value of the function is negative here. Again here value of the function is positive, and till here it is positive. And here the value is 0. At this point the value is 0. At this point the value is 0. At this point value is 0. Correct? Now let us talk about slope. Now let us talk about slope. Now slope is positive here, 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 here. Here slope is 0. Why? Because it has become horizontal. Slope is negative here. It is negative. Slope is negative. And here slope is 0. Why? Because it has become horizontal. Again slope is positive here. Why? Because if you draw a tangent, it will make acute angle with x-axis. Here slope is 0. Again here slope is negative. Why? Because if you draw a tangent here, it will make obtuse angle. Okay. So all the lines that appear like this, like this, like this, or like this, the slope is positive. And all the lines that appear like this, like this, like this, the slope is negative. Remember. Okay. So if you move from this point to this point, if you move from this point to this point, delta y is positive and delta x is also positive. Delta y is positive and delta x is positive and delta y is also positive. But you are moving on the section where you have negative slope. What will happen? If you move from here to here, what will happen? Delta x is positive but delta y is negative. So slope is negative. Clear? So negative and positive slope should be clear for you. Negative and positive slope should be clear for you. Okay? Now, what about this? Y equals to x square. So this is y, this is x. If I plot y is equal to x square, you will get a graph like this. This is graph for y is equal to x squared. Why the graph will be like, why the graph will be in this shape? Because you can plot and see for 0, y will be 0, for 1, y will be 1, for 2, y will be 4, for 3, y will be 9. So y is increasing more rapidly, that's why it will curve upwards. Okay, it will curve upwards. Whereas minus 1 is also plus 1, minus 1 squared, minus 2 squared is plus 4, minus 3 squared is plus 9. That's why this graph is also symmetric about y-axis, because the value of y will be same on the positive side of x as well as on the negative side of x, and it will be symmetric. So this is the graph. Now what about the values of this graph? The value of this graph is 0 here, and it is always positive whether you go on the right side or you go on the left side. The value of this graph is positive. But what about the slope? Slope is positive here and slope is 0 here where the value is 0, and slope is negative here. Slope is negative. Why? Because if you draw a tangent there, it will make obtuse angle with positive x-axis, and if you draw a tangent on the positive side, it will make acute angle. Here it will make obtuse angle. So that's why the slopes are positive here, negative here, 0 here, and so on and so forth. Clear? Okay. Anyway, now let us see what dy by dx is. So if y is equal to f of x equals to x squared, okay? If y is equal to f of x is equal to x squared, what is dy by dx? What is dy by dx? Nothing but slope of function at any x, which is also equal to f dash of x according to Newton's notation. So what is it? It is f of x plus dx minus f of x by dx. This is the fundamental theorem of calculus, right? So what is x plus dx? F of x plus dx, it is x plus dx whole squared minus what is x? F of x, it is x squared by dx. Now if I expand this, a plus b whole square is a square plus 2ab plus b squared minus x squared, correct? So this will be something like this by dx, correct? Now what will happen? This x squared and x squared will cancel. What will remain? 2x dx plus dx squared by dx. This will remain. So what is this actually? So if I separate it, you'll have 2x here plus dx. Now the thing is, whenever something is very small, when you add it, you can neglect it. You can consider it to be 0. This is negligible. Negligible. Okay. So whenever something is small, you can neglect it in addition, not in multiplication. Whenever something is small, you can neglect it in addition, but in multiplication, you cannot neglect it. Okay. So here it is dx is being added, and dx is a small value. I told you already. Delta x is a significant value, dx is an insignificantly small value. Okay, so dx. So what is dy by dx? According to our definition, it's 2x. Clear? Dy by dx is 2x. Okay, dy by dx is 2x. So what was the question here? What if y equals to x square? What was dy by dx if y equals to x square? Okay, so let me repeat that. If y equals to x square, then dy by dx is 2x. Now let us see graphically what does that mean. Okay, let us see graphically what does that mean. Watch carefully. This is your y equals to x squared. This is your y equals to, this is y, this is x, and this is y equals to x squared. Y equals to x squared plotted on the Cartesian plane. Okay, now here I am plotting 2x. How will be the graph of 2x? So graph of 2x will be something like this. It is a straight line. Y is equal to mx plus c, where c is 0. If c is 0, it should touch y axis at 0, because y intercept is 0. So it is passing through origin. Y is equal to 2x. This is what? I'll not write y, I'll write it as z, some other variable. So this is z. So this graph is for z is equal to 2x. Okay. What is z equal to? Z equals to dy by dx. Z equals to dy by dx. Now does this make sense graphically? Yes, it makes sense. Why? Because see, here the slope is 0, so here its value is 0. See, the value of z is equal to slope of y, is equal to slope of y. Why? Because z is dy by dx, and dy by dx is nothing but slope. Dy by dx is nothing but slope. Clear? So let us see. Here the slope is positive and it is increasing. Yes, here the value is positive and it is increasing, because value of this must be equal to slope of that. And here the slope is negative and the negative value is increasing. It is becoming more and more steeper. Okay, so here also the value is becoming more and more negative, and here it is 0. So graphically also these two match. What match? The slope of x square and the value of 2x. Whatever the slope of x square is at that point, at that x, okay, whatever slope of x square is at any x, the value of 2x will be equal to that. Okay, that means the value of 2x will be equal to slope of x squared. Why? Because 2x is the derivative of x squared. 2x is the derivative of x squared. That means what? 2x is the derivative of x squared. That means what? Derivative is nothing but slope. So 2x is the slope of x squared. That means slope of x squared is equal to value of 2x at various points x. Clear? So this is the story of x squared. I will derive the derivative of x squared in another method. Okay. Suppose you have a square. Suppose you have a square. Now the area of that square is y, and the side of that square is x. Side of that square is x. So area is what? Area is y and side is x. So what is the relationship between x and y? The relationship is this: y equals to x squared. Y equals to x squared. Clear? Now if I increase the value of x by a small amount, the area will also increase. The area will also increase. So I increase the value of x. So both the sides will increase, because side of a square is now x plus dx. Okay, so this is x plus dx. This is also x plus dx. So what will happen? There will be an increment in value of x. So the side will increase little bit like this. So the square will also become little bit bigger. Now your area has also increased. By how much? Your area is increasing by this much amount. By this much amount, your area is increasing. This is the uh, new additional area that you have. So what is that new additional area? Let me try to find out. So I am dividing it into three sections. Two long rectangles you get. So what is the area of this rectangle? So this is dx, right? This is dx. This is also dx. So the breadth of this triangle is dx, the length is x. So this is x, this is x, this is x, this is x. So original square. So what is the area of this? What is the area of this rectangle? This red rectangle. It is x, which is the length, and dx, which is the breadth. So this is the breadth and this is the length. So this is dx and this is x. So x dx. Similarly, what is the area of this rectangle? Same. Again, length is x and breadth is dx. So x dx. So two red rectangles. What about this square? Blue colored square. This blue colored square. It is dx into dx. It is a small square. So it is dx squared. So what is the increase in area? See, y was the area, right? Y was the area. If y is area, increase in area is written as dy. See, if x is the side, dx is increase in size. Sorry, if dx is the side, if x is the side, dx is the increase in side. If y is the area, so if x is the side, dx is the increase in side. If y is the area, then dy is the increase in area. Now tell me what is increase in area, dy? It is equal to this red area plus blue area. So it is equal to this red area of these two rectangles plus the blue area of that square. So what is the net increase in area? It is 2x dx because there are two red areas plus dx squared, correct? Plus dx squared. So if I divide this equation by dx on both sides, I'll get dy by dx equals to 2x dx plus dx squared by dx. So which is dy by dx equals to 2x plus dx. Again, same story. Dx is a small value, so when added, it can be neglected. It can be neglected. So what is dy by dx? So what is dy by dx? It is 2x again. Dy by dx is 2x. So again, if y is equal to x squared, which is equal to f of x, then the derivative dy by dx equals to f dash of x can be written as f dash of x is equal to 2x. So this is the second proof that I have given for this expression. If y is equal to x square, and then dy by dx is equal to 2x. dy by dx is equal to 2x. Clear? Now let us go for x cubed. Let us go for x cubed. Now, first let us draw the graph for x cubed. So this is x, this is y. What graph we are intending to draw? Y equals to x cubed. Now the graph will be something like this. Now I can draw the graphs easily because I have been seeing these graphs for so many years. But if you do a little bit of practice, you too can. So this will be the graph for y equals to x cubed. Why? Because at 0 value of y is also 0, at 1 it will be 1, at 2 it will be 8, at 3 it will be 27, and so on and so forth. At minus 1, cube will be minus 1 because you are multiplying negative number 3 times, so it will be minus 1. At minus 2, it will be minus 8. At minus 3, it will be minus 29. That's why unlike y equals to x, graph of y equals to x square, the graph is not positive on both sides. On the right side it is positive, but on the left side it is negative. So this graph is not like x squared, which is positive on both sides. This is negative on the left side and is positive on the right side, because when you multiply a negative number 3 times, you'll get a negative value. Okay, clear? Okay. Now let us try to see what the derivative of this function is. Now f of x is what? X cube, which is equal to y. So y equals to f of x is equal to x cube. So what is our fundamental theorem of differential calculus? What is the fundamental theorem of differential calculus? It is f of x plus dx minus f of x by dx, which is equal to dy by dx. Okay, so this is change in value of y, f of x plus dx minus f of x, and change in value of x is anyway dx. So this is the fundamental theorem of calculus. So if I use this, what will I get? If I use this, what will I get? If I use this, I'll get x plus dx whole cube minus x cube by dx equals to dy by dx. So if I expand this, what is a plus b whole cube? It is a cube plus 3a square b plus 3ab square plus b cubed. So this is a plus b whole cube minus x cube by dx, correct? Now what will I get here? So this x cube and x cube will cancel. So the remaining thing is 3x squared dx plus 3x dx squared plus dx cubed by dx, correct? So if I separate all the three parts, what will I get? 3x squared plus 3x into dx. Why? Because 1 dx will cancel, plus dx cubed by dx, which is dx squared. Now the thing is, I can neglect dx into 3x because dx is a small number like 0.000001. If you multiply it with any number, like for example 3, you will get 0.000003, and that itself is small. So when that is added to something else, it is negligible. So this is also negligible. So these two are neglected. Why? Because they are small values. Clear? So what will remain? 3x squared will remain. So what is the conclusion here? What is the conclusion? Conclusion is this. Conclusion is, if y equals to x cube, then, or which is equal to f of x, then f dash of x is equal to dy by dx is equal to 3x squared. Clear? So we derived derivatives for three functions till now. Okay. Anyway, I'll give you an alternate proof. I'll give you an alternate proof for this thing. But before that, let us check the graph. Let us check the graph, whether graphically it is correct or not. Okay, let us check the graph. So what was the graph of x cube? The graph of x cube was something like this. This was the graph of x cube. So this was the graph of y x. This is y equals to x cube. Clear? What was the derivative of this? I'll write the derivative in green. It was 3x squared. So let me write dy by dx. Let me give you another variable for it as z. So here I am writing z. Okay. So how will be the graph of 3x squared? It will be just like x squared only, but it will be little bit more skinnier. Okay, because you are multiplying a factor of 3, so it will have that stretching along the y-axis. It will be skinnier. So the graph will be something like this. Now the slope of this function should be value of this function. Let us see. So what is the slope of this function? It is 0 here. So here value is 0. Here slope is positive, right? Why? Because this line, if you draw a tangent, it will make acute angle with x-axis. So slope is positive, here value is positive. Slope is positive, here value is positive. And here also slope is positive. You know why? If you draw a tangent here, it will still make acute angle. So here also slope is positive. All the lines that look like this will have slope positive. All the lines that look like this will have slope negative. So here slope is positive. So here value is positive. Why value is positive here? Because it is lying above x-axis. So even graphically, it is making sense. What is making sense? If y is equal to x cube, then the slope of y dy by dx is equal to 3x squared. So this is making sense graphically also. Okay. Now last derivation let me make for 3x squared. Let me let me take a cube. Let me take a cube of side x. What is the meaning of cube? Cube is a cuboid which has all three sides equal. So this is what? A cube. Now let the volume be defined as y. What is the volume of the cube? So let the side of the cube be x. So this is x, and this is x. So in x direction also it is x, in y direction also it is x, and in z direction also it is x. So all the three dimensions are x, x and x. So what is the volume? Volume is y. Volume is y. So what is volume defined as? Y equals to x cube. Y is what? Volume. So y is equal to x cube. That means we got the function that we were talking about. Y is equal to x cube. Now if I increase the value of x by dx, what will happen? All the three sides will increase. All the three dimensions will increase. So x will increase here in this direction. X will increase in this direction. And x will also increase in the upward direction also. Correct? So the extra volume that you get is this volume plus this volume plus this volume. These three volumes, extra volumes you'll get. And here you will have one pillar like this. Here you will have another pillar like this. And here you will have a small cube. Okay. So here, okay, 1 second. Here you will have one pillar. Here you will have one pillar. Here you will have one pillar. Okay. Anyway, we have these three slabs. First, this red slab above, red slab on the front, and red slab on the side. What is the increase in value of increase in volume? Increase in volume can be given as dy. So if you look at this, the increase in volume is equal to increase in the volume of these three extra slabs. It is equal to the volume of these three extra slabs. What are these three extra slabs? Okay, let me just remove this red color. It is disturbing. So increase in value of y is how much? Dy. So it is equal to increase in volume of these three extra slab. One slab on the front, one slab on the side, one slab on the top. So the base of that slab is x squared and the height of that slab is dx. So there are three slabs. I am writing 3x square into dx. So these three slabs I have written. So this is the slab, right? This is the slab. This whole thing is a slab. So there are three slabs, one on the top, one on the front, and one on the side. Then there are three pillars. These pillars, if you see these pillars, there are three pillars. There is one pillar here, and one pillar here. Now the base of the pillar is dx squared, and the length of the pillar is x. So it is 3 because there are three pillars. So the base is dx squared into height is x of that pillar. Plus there is a small cube also here. There is a small cube. There is a small cube here whose volume is dx cube. So that will also get added up if you increase what? The value of dx. Clear? So what will you have? Dy equals to 3x squared dx. So 3 slabs plus 3 pillars, 3x dx squared plus one small cube. So I think it is a little bit difficult to visualize here, but if you think, you'll understand that if a side of cube has increased, there will be 3 slabs that add up. One on the front, one on the top, and one on the side. And there will be 3 pillars between those slabs, and between those pillars there will be a small cube. Okay, so this is the total increment in area. Now if I divide the equation by dx on both sides, what will I get? 3x square dx plus 3x dx squared plus dx cube divided by dx. So what will I get? dy by dx equals, so if I separate all the three parts, I'll get 3x squared, dx will cancel, and dx square by dx is dx, and dx cube by dx is dx squared. So because dx is negligible, dx square is also negligible, I can take it as 0. And when you multiply a negligible number to something, it will also become negligible, and when you add it to something else, it will be almost like 0. Clear? So what is dy by dx again? 3x squared, which we already got. Okay? So dy by dx is 3x squared. Clear? Okay. So this is done. So we have derived derivatives for three or four functions here. So y equals to f of x. So this was the function and this was the derivative. So derivative is either written as dy by dx or it is also written as f dash of x. So first derivative that we derived was for what? Y equals to mx plus c. What was the derivative? It was m. Slope was constant. For x, what was the derivative? 1. For x squared, what was the derivative? 2x. And for x cubed, what was the derivative? It was 3x squared. Clear? And next question I will ask you is, what will be the derivative of a constant? Derivative of a constant, it will be 0. Why derivative of constant is 0? You can check using the formula. So what is our formula? F of x plus dx minus f of x by dx is what? Dy by dx, right? So if f of x is c, f of x plus dx is also c. So c minus c is 0 by dx. So it is 0 by dx. Now this 0 is actual 0. This dx is a number that is close to 0, like 0.0001. So 0 by 0.0001 is still 0. That's why slope is 0. Or dy by dx is 0. That means if function is c, its derivative is 0. Or for any constant function, its slope is 0. Graphically, you can check that. Graphically, if you see, how will be the plot of a constant function? How will be the plot of a constant function? This is x-axis and this is y-axis. If I plot this function, it will be something like this. And its value will be c. Everywhere value is c. For any value of x, value is c. Now, what is the derivative? What is the derivative? Derivative is nothing but slope. Now, no matter where you stand on this line, no matter where you stand on this line is anyway horizontal, right? This line is anyway horizontal. So, slope is 0 everywhere. That's why if y equals to constant, dy by dx is 0. This is what? Slope. Slope is 0. Or you can look at it in another way. You already know what you know. If you have a function y equals to mx plus c, slope is m. Slope is m, correct? But what if you have this function y equals to c? Here still you have mx. Okay, what about y equals to c? So here y equals to c, here you have mx, you have mx here, but m is 0 here. M is 0. M equals to 0. That's why this is 0. That's why it is becoming y is equal to c. And you know that slope is m. If slope is m, then for y is equal to c, where m is 0, slope is anyway 0. And what is m equal to? Or what is dy by dx equal to? It is equal to m, which is 0. So either way you can see that slope is 0. Clear? Either way you can see that slope is 0. Clear? Now, next question, next topic. Let us come to trigonometric ratios or trigonometric functions. Now trigonometric functions, the first function is y equals to sin x. Now first I have to plot this y equals to sin x. How will be the plot of y equals to sin x? So plot of y equals to, so this is a x-axis and this is your y-axis. Okay. Now the plot of y is equal to sin x will be something like this. I'll tell you why. And here also it will be like this. This is a periodic function. What is the meaning of periodic function? The function, the pattern will keep on repeating. Now at 0, sine 0 is 0. And the value is positive in first quadrant. So till pi by 2, the value will increase. It will become what? From 0 to plus 1. In the second quadrant again, sign is positive only. Correct? So till 180 degrees, till pi radians also it is positive. And then it will enter the third quadrant. In third quadrant it is negative and it is the most negative at 3 pi by 2. 3 pi by 2. And then again the value will keep on value will still be negative in the fourth quadrant also. So basically this is your first quadrant, this is your first quadrant, this is your second quadrant, this is your third quadrant, and this is your fourth quadrant. Okay. Now after coming into fourth quadrant, again it will enter into first quadrant and everything will repeat. That's why this will repeat for one more cycle, and this will repeat for one more cycle, and it will keep on repeating forever, because you can keep on going around and come in circles. Okay, it will never end. That's a periodic function, and you can go back also. You can, from first quadrant, if you go back, you will enter into fourth quadrant, then third quadrant, then second quadrant, then again first quadrant. So you can go back also. So on the negative scale also, this will keep on repeating. So this is a periodic function. This is a periodic function. Clear? So sin x is a periodic function. Now what will be the derivative of sin x? So what is the derivative of sin x? What is derivative in the first place? Derivative is the slope. Derivative is the slope. So let me draw a little bit bigger so that it will be easier to see. So the plot of sin x will be something like this. Plot of sin x will be something like this. And it is a periodic function, and it will extend from minus infinity to plus infinity. So it can go all the way to the right, and it can go all the way to the left. But in the y direction, it will lie between plus and minus 1 only. Plus 1 and minus 1, because the value of sine cannot exceed plus 1 and it cannot go less than minus 1. So on in the y direction, the reach of this graph is limited, or it is bounded by plus 1 and minus 1. But on the x-axis, it extends from minus infinity to plus infinity. Correct? Now if I want to find the derivative is nothing but slope. Here the slope must be something positive. It should be positive here, it should be positive here. Here slope should be 0, and here the line is making negative slope. What is the meaning of negative slope? If you draw a tangent, it will make an obtuse angle. Okay. Or it is very easy to see when slopes are negative and positive. I am repeating again. If the lines are something like this, slopes are positive. If the sines are something like this, slopes are negative, because these make acute angles with horizontal positive x-axis. These make obtuse angle with horizontal lines. So anything like this is positive, anything like this is negative. So if I write the slope, okay, here slope is positive, 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 0. Here slope is negative, 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 0. Slope is positive, 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 0, negative, negative. So here slope is negative, and here also slope is negative. Again here slope is 0, here slope is positive. Okay, so it is very clear. Now what about values? Values are positive above the x-axis and negative below the y-axis. Positive above the x-axis, negative below the x-axis. So here slope is negative, negative, negative. Slope is positive, positive. Here slope is positive, and here, sorry, I'm talking about values. So green is value of function, red is slope of function. Clear? So So derivative also should correspond to or should satisfy these properties. So what is the derivative of sin x? Let us try to see. Watch carefully from here. Okay. So if y equals to sin x, what is dy by dx? It is f of x plus dx minus f of x. This is f of x, right? X plus dx minus f of x by dx, correct? So if I put this sin x here, what will I get? Sin of x plus dx minus sin of x by dx. So this is your dy by dx, correct? Okay. Okay. So let us proceed with this. Let us proceed with this. So what is sin a plus b? Sin a plus b is sin a cos b plus cos a sin b. So this is the expansion of this, and minus of sin x by dx. So what will you get here? See, dx is small, right? That means almost 0. What is cos 0? Cos 0 is 1. So I can write it as 1. And sin x will cancel. So what will remain? What will remain? So this has cancelled. So cos x sin dx by dx. But I already told you, when theta is small, sin theta is equal to theta. When theta is small, sin theta equals to theta. Correct? Sin theta equals to theta. So dx is small, right? Dx is a small number. That's what the property is of dx. So sin dx must be equal to dx. So this dx and dx will cancel, and what will remain? Cos x. So what was the question? If y was equals to, if y was equal to sin x, implies dy by dx is equal to cos x. So derivative of sin x is what? Cos x. Derivative of sin x is what? Cos x. So this is the derivation. Okay. 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 Fine. So this is this is the conclusion. So okay, let me just repeat what we did. So we took if y was equal to sin x, what was was equal to f of x, what was dy by dx, or f dash of x equal to. We applied the formula, and after application of formula, what we got? See, y was equal to sin x, so f of x plus dx is sin of x plus dx minus sin x. What is sin of x plus dx? We derived yesterday. The expansion for sin a plus b was sin a cos b plus cos a sin b. Now here you don't have a and b, here you have x and dx. So you'll have sin x cos dx plus cos x sin dx minus sin x. But dx is small, so it is almost 0. So cos 0 is what? 1. Cos 0 is 1. So here cos dx becomes 1. So 1 into sin x is sin x, and this sin x and this sin x cancel because there is a negative sin x here and positive sin x remains there. So what you are left with? You are left with this cos x sin dx by dx. But I already told you in the first class that when theta is small, sin theta equals to theta. When theta is small, sin theta equals to theta. We also visualized it geometrically, why it is true. So sin theta and theta are equal when theta is small, and dx is anyway small. So sin dx is equal to dx. So sin dx and dx cancel. So what is remaining? Cos x. So derivative of sin x is what? Cos x. Derivative of sin x is what? Cos x. Now if you look at the graphs of sin x and cos x, if you look at the graphs of sin x and cos x, how will they be? Okay. Now, if you look at the graph of sin x, the graph will be something like this. Okay. This is graph of y equals to sin x. Now, if you look at graph of cos x, if you look at graph of cos x, see, if I plot correspondingly, so for sin x, this was pi by 2, right? This was pi by 2, this was pi, this was 3 pi by 2, this was pi, and sorry, this was 2 pi, and then again it is the cycle is repeating. So cos x, graph of cos x will be how? Cos x is 1 at 0, and at 90 degrees, sorry, it will be 1 at angle 0, this is angle 0, and it will decrease, cos value will decrease, and it will become 0 at 90 degrees at pi by 2, and it will enter second quadrant where cos will be negative, and it will reach -1 here, and again it enters third quadrant. This is first quadrant, this is second quadrant, this is third quadrant. Third quadrant it is still negative, that's why it is below x-axis, and it will be 0 again at 270 degrees. After 270 degrees it enters fourth quadrant where it's positive, so it will complete fourth quadrant. This is fourth quadrant, and again it will enter first quadrant, and the cycle will repeat. So this is also a periodic function. So this is z is equal to, this is z axis, cos x, correct? Now, what is the derivative of sin x? Derivative of sin x is, what is derivative of sin x? It is cos x. That means slope of this white graph should be equal to value of green graph. Slope of white graph should be equal to value of green graph. Okay. So here slope is like, it is making 45 degrees, right? Almost. So slope is +1. So its value is +1. Here slope is 0. Here its value is 0. Here slope is -1. Why? Because it is making almost 135 degrees. Here value is -1. Here slope is 0 again. Here slope is 0. Here its value is 0. Correct? Here slope is +1 again, and here value is +1. Correct? Here slope is 0 again, and here the value is 0. So graphically also, the you know uh, slopes and values are making sense. So if let me repeat, if y equals to sin x, dy by dx is equal to cos x, correct? So let this be what? Y equals to sin x. So z equal to what? Let let z be equal to cos x. That means slope of y is equal to value of z. Slope of y is equal to value of z. Why? Because z is the derivative of y. Z is the derivative of y. So derivative of y is slope of y, which is equal to z. Therefore, value of z is equal to slope of y. So here in this graph, there are two graphs, white graph and green graph. The slope of white graph will correspond to value of green graph. Okay, wherever the slope is 0 of the white graph, value of the green graph will be 0. Value of the green graph will be 0. Clear? Okay. What about y equals to cos x? Y equals to cos x. If you have another function, till now we were looking at y is equal to we were looking at y equals to sin x. So what if y equals to cos x? So according to our which is equal to f of x. According to our formula, f of x equals to y. If f of x is equal to y, then dy by dx is equal to f dash of x, which is equal to f of x plus dx minus f of x by dx. This is the formula for slope, change in value of y, which is dy, which is also equal to f of x plus dx minus f of x by dx. So what do you have here? What do you have? Cos of x plus dx, because f of x is cos x, so f of x plus dx is cos of x plus dx minus cos of x by dx. Correct? So what will you get here? Cos a plus b is cos a cos b minus sin a sin b. We already discussed that. So cos a cos b minus sin a sin b. So this is the expansion of this, minus cos dx, sorry, minus cos x, that is. Let me clean that. Minus cos x, this thing, okay, by dx. Now if I expand this, what will I get? See, dx is small, so cos of dx is what? Cos of 0, almost 0 is 1. So this is almost 1. So what will remain here? Cos x will remain. If cos x will remain, this cos x and this cos x will cancel. So what you are left with is minus sin x sin dx by dx. Correct? But dx is small. Therefore, sin dx equals to dx. So this and this will also cancel. So what you are left with? You are left with minus sin x. You are left with minus sin x. Correct? What is the conclusion now? The conclusion is this: if y equals to cos x, implies dy by dx is minus sin x. Now you can check it graphically again. You can check it graphically. Let me draw the graph of cos x. We have already drawn the graph of cos x. Now graph of cos x is something like this. So it will start at 1, it will become 0 at 90 degrees, then it will enter second quadrant, it is negative, third quadrant, it is negative, fourth quadrant, again it is positive. Again it will repeat it will enter first quadrant, and this cycle will repeat. So this is pi by 2, this is pi, this is pi, this is 3 pi by 2, this is 2 pi, correct? This is 2 pi, and so on and so forth. So this is your first quadrant, this is second quadrant, third quadrant, fourth quadrant, again first, and it will repeat again. So this is the graph of what? Cos x. What will be the graph of sin x? We don't want sin x. We don't want graph of sin x. We want graph of minus sin x. So this is graph of cos x. So this is graph of cos x. Y equals to cos x. Here let us take z equals to minus sin x. So we have seen the graph of sin x. So minus sin x will also be similar, but it will be inverted. It will be inverted. So minus sin x, the graph will be something like this. Let me draw in white, and it will be visible. So inverted sin x graph will be like this. Why? Because sin x will start from the top. This will start from the bottom. Why? Because wherever sin x is positive, minus sin x should be negative. Therefore, everything is opposite. In first quadrant, sin x is positive. In first quadrant, minus sin x is negative. In second quadrant, sin x is positive, minus sin x is negative. In third, it is negative, here it is positive, and so on and so forth. Correct? Again, it will enter first quadrant, second quadrant, and this will repeat. Now, minus sin x is the slope of cos x. Minus sin x is the slope of cos x. So let us see. Let us see. Here the slope is 0. Here the value is 0. That means slope of yellow line should be equal to value of white line, because you know this white line represents minus sin x, which is nothing but derivative of cos x, which is nothing but slope. So here the value slope of yellow line is 0, value of yellow line is 0. Here the slope is negative of yellow line, here the value is negative of white line. Here the slope is 0. So here of yellow line, so here the value of white line is 0. Here the slope is positive of the yellow line, here the value is positive. Again, here the slope is 0, here the value is 0. Correct? Here the slope is negative, here the value is negative. That means it confirms that slope of cos x is minus sin x graphically also. Clear? So now we learned what? Two more formulas. What are the two more formulas we learned? These two. If f of x is y equals to f of x is this, what is the value of dy by dx or f dash of x? So I'll write again all the things we learned till now. I'll write again. The first thing was what? Y equals to mx plus c. Slope was m. So if it is c, slope was 0 for constant function. If it was y equals to, sorry, y, no need to write y because y I have written in the table above already. So I don't need to write y here. Okay, c. So anyway, so if y is equal to x, slope is 1. If y is equal to x square, slope was 2x or derivative was 2x. If it was x cubed, it was 3x squared. Correct? So let me extend it. Okay. So it was when it was sin x, it was cos x. When it was cos x, it was minus sin x. It was minus sin x. Correct? So these things we have learned till now. Okay. So there are few more, but before that, I'll go to some. I'll make an observation here that if you have a function x power n, if you have a function x power n, then its derivative must be n into x power n minus 1. See, it is true for x square. So x power 2, the 2 comes in the front and the power becomes 2 minus 1. So it is 2x. So this formula is making sense here. It is also making sense here. Why? Because x cube n is 3, 3 comes in the front and power is n minus 1, which is 3 minus 1, which is equal to 2. And it is also making sense here also. Why? Because here the power is 1, 1 comes in the front and x power 1 minus 1 is x power 0. X power 0 is 1 again. Okay. And here also it makes sense because c is nothing but x power 0. C is nothing but c into x power 0. So that 0 comes in the front and it becomes 0. But it doesn't prove that the derivative of x power n is n into x power n minus 1. It is just an observation that it may be. Till now it is correct. I do not know what happens to x power 4. But till x cube it is making sense. So let us try to take the derivative of x power n first. Okay. So if y is equal to x power n, which is equal to f of x, what is dy by dx? What is dy by dx? So I made a guess that it is n into x power n minus 1, but what is the proof? So let me try to prove this. So what is the derivative f of x plus dx minus f of x by dx? This is your derivative, right? So I have to put this here. I have to put the value, or I have to substitute to check whether that is the case or not. So f of x plus dx is what? X plus dx whole power n minus what is f of x? It is x power n by dx. Correct. Now what is x plus dx whole power n? It is x plus dx multiplied n times. So basically I have to multiply this n times to get f of x plus dx whole power n. So this is the thing, right? If you observe carefully, what will be the first term in all the multiplications? The first term will be x power n. When you will get x power n, you get x power n when you take x from each and every bracket. From this bracket you have to take x. From this bracket also you have to take x. From this bracket also you have to take x. And all the way from each and every bracket you have to take only x. So there is only one way of doing that. That is taking all the x's. That's why you'll get x power n only one time. Plus next term will have x power n minus 1 times dx. This term you will get when you take dx from any one bracket and all the rest of the brackets you take x. Okay. So while multiplying, you take dx from any one of the brackets or from any one of the parentheses and take x from all the rest. So in how many ways you can choose dx? You can choose dx from the first bracket and rest of them you can multiply by x. That is your first option. Second option is you can choose dx from the second bracket and all the rest of the brackets you take x. Or you can take dx from the third bracket, correct? And you can take x from all the rest of the brackets. Or you can take from the fourth. And so on and so forth. You can go up to nth bracket. You can take dx from the nth bracket also. Okay. And you can multiply x's with the x's of the all other brackets. Let me repeat what I just told. So let me repeat. So in order to get this term, this second term, you can take dx from the first bracket and all the rest of the brackets you should take only x, not dx. All the rest of the brackets you have to take x, so that you will get x power n minus 1. That is first option. Second option is second option is second option is take dx from the second bracket. You will get dx here and multiply x's from all the rest of the brackets. You will get second similar term. Okay. Now third possibility, you should take dx from the third bracket and all the rest of the brackets you have to multiply by x. That is third possibility. In that way you can do it n times because you have nth bracket. And last, you can take dx from the nth bracket and all the rest you multiply by from all the rest of the brackets you multiply x. So in how many ways you can get this term? You can get this term in n ways, because from each and every bracket you can get one dx and rest of them you can multiply by x. So you'll get n terms. Plus you'll have several other terms like x power n minus 2 into dx square. These kind of terms you'll get when you take two dx's from two brackets, and from rest of the brackets n minus 2 brackets you have to multiply x. And you will get so many terms. Dx cubed you will get, dx cube into something, dx power 4 into something you will get, and so on and so forth. So I'm not interested in that. Why? I'll just tell you. Why? Because see, so first term I am getting x power n here in this. Second term I am getting n into x power n minus 1 into dx. Plus I'll get dx squared interested in. Why? Let me explain. Okay, so this is the expansion of this yellow box. So there is minus x power n here. So that also I have to write minus x power n by dx. So by dx, this dx I am writing here. Correct? So what will happen? This x power n and this x power n will cancel. Correct? So what is remaining? You have n into x power n minus 1 into dx by dx. So dx will cancel, and what will remain? N into x power n minus 1. Plus this dx will divide this dx square and dx will remain. Okay, after dividing this by this into something that I am not interested. Now you see why I am not interested. Because whatever that value is, dx is a small number, and dx multiplies that any number, this will together become negligible, and I can anyway neglect it fully. That's why I'm not interested in this. Whatever it will anyway become negligible, because at the end there is a factor dx multiplying it. So what is remaining? N into x power n minus 1. So we started with what? Y is equal to x power n, and we applied the formula for dy by dx. You got n into x power n minus 1. So we proved just now that derivative of x power n is n into x power n minus 1. Clear? So we derived, okay, let me just summarize what we derived. So we derived the derivative for mx plus c, it was what? It was m. We derived for x, which was 1. We derived for x squared, which was 2x. We derived for x cubed, which was 3x squared. We derived for x power n, which was n into x power n minus 1. We derived for sin x, which was cos x. We derived for cos x, which was sin x. One derivation I will not do here because of the time constraint. Generally I do in normal classes when the time for preparation is 1 year or 2 year, because now there is no enough time. I will not derive it here, but you just remember I'll derive it in some extra lecture, but not here. Derivative of e power x is e power x. Derivative of e power x is e power x. That means if y equals to e power x implies dy by dx is also e power x. That means what? E power x is a special kind of function whose slope is equal to its value. Whose slope is equal to its value. This function you will come across a lot of times in your syllabus, or maybe if I get time someday later, I will derive it. But for now, you remember that e power x is such a function whose slope is equal to its value. Okay, slope is equal to its value. Okay, that means whatever the value of function is, that will be its slope. That means if value is increasing, slope will also increase. If value is 0, slope is also 0. But generally e power x will not have value 0 except at a point minus infinity, because e power minus infinity is what? uh, 1 by e power infinity. So 1 by e power infinity is 1 by infinity. E power infinity is infinity. So there you will have 0. 1 by infinity is 0. But except that point, e power x will not have 0 slope anywhere. It will have positive slope only, because e power x can only be positive for any value of x. Whether x is negative or positive, e power x is always positive. Okay. So, and let me draw the graph of e power x just for understanding how the sketch of e power x looks. So this is x, this is y equals to e power x. Let me draw the graph. The graph of e power x looks something like this. So notice, as the value, this is the value, right? As the value is increasing, slope is becoming more. As the value is decreasing, slope is becoming less. Here slope is lesser. Here slope is lesser. Note that this graph doesn't exist below the x-axis. This graph doesn't exist below the x-axis. That means the value is never negative. So slope is also never negative. Okay, slope is also never negative. And why is this graph like this? Okay, it is e power x, right? Value of e is 2.718 and so on. So it's a very special number, value of e. E is a transcendental number, just like pi. So that means it is non-terminating, non-repeating decimal. So it's a special kind of decimal, just like pi. And how did they arrive on this value? There are various methods. So those are advanced for you. Only the people of mathematics do. If you are interested after the exam, I will go into that. But before the exam, you don't require. So this is some 2.7 something. Okay, so at x is equal to 0, value is what? 1. Why? 2.718 power 0 is anyway 1, and at x is equal to 1 the value will be how much? 2.718 and so on. So here the value will be e, and here it will be, at 2 it will be e square, at 3 it will be e cube, at half it will be what? Root of e, and so on and so forth. So, sorry, at half it will be 1 by, at minus 1 it will be 1 by e, at minus 2 it will be 1 by e square, at minus 3 it will be 1 by e cube. So the graph is something like this. So this is the graph of e power x. This is the graph of e power x. So what you need to remember is, If you have function y equals to e power x, then is equal to f of x, then dy by dx or the derivative is also e power x. You just remember this. I will prove it someday later. You just remember it. So you have learned derivatives of all these functions. Okay. Now let us start some other important tools in derivatives, and then based on that we will derive derivatives of some other functions. Okay, and the tools I'm going to or the tools that I'm going to discuss now are also important in solving problems. The first tool I want to discuss in derivatives, or the first rule I can say that I want to discuss in derivatives is the chain rule. What is that called? It is called the chain rule. The chain rule. So this is very important. Okay, chain rule. Now, why is chain rule required? I'll just explain what chain rule is and why is chain rule required. After chain rule, I'll discuss product rule. So suppose you have function like y is equal to sin x. So you can easily write what dy by dx is. What is dy by dx? It is cos x. We just saw that. Now, if you have function like y equals to x squared, then you can write dy by dx as 2x, correct? So these two things are okay for us. But what if I have a function like y equals to sine of x squared? I do not know what the derivative is. So now if he asks me what is dy by dx, so now if the question is this, what is the question? The question is this: what is dy by dx? I can't answer this because I do not have any such kind of formula yet. Okay, I know how to take out the derivative of sin x. It is cos x. I know what the derivative of x square is. It is 2x. But I do not know what the derivative of sine of x squared is. So here I use something called the chain rule. So chain rule is, see, what I do is here I'll assume let x square equals to u, some other variable. So here what is du by dx? Sorry, what is du by dx? It is 2x. It's just a change in variable. If y is equal to x square, dy by dx is 2x. So if u is equal to x square, du by dx is 2x. Okay, fine. So what will this function become? This will become y equals to sine u. Now see, y is a function of u here, not function of x. So I cannot use dy by dx. I can use dy by du, which is nothing but cos u. Same thing, same thing like this. If y is equal to sin x, dy by dx is cos x. Now if you replace x by u, you'll have this. Same thing. In place of x, you have u. So y is equal to sin u. So dy by dx is equal to cos u. Okay. Now, but I don't want dy by du. I want dy by dx. So what will I do? Dy by du into du by dx. Correct. So what will I get here? I'll get this du will cancel and I'll get dy by dx. Correct. This is what I'm intending to find. So what was dy by du? So dy by du was cos u. Du by dx was what? Du by dx was 2x. So my answer is cos u into 2x. But u was not given in the question. I assumed what that variable to be u. U was equal to what? X squared. So I have to substitute that. So my answer is cos of x squared into 2x. So dy by dx is equal to cos of x squared into 2x. Clear? Now what was the question here? Question was this: y was equal to sine of x squared. What is dy by dx? Dy by dx is cos of x squared into 2x. So if you do this in this long process, you will have to do like this. But the chain rule is the is the summary of this method actually. The chain rule says that if you have any function, if you have any function where in place of x you have something else, and you want to take out the derivative of that, then assume that thing to be okay x only. Okay, leave it as it is. Now if there was x here, what would be the answer? It would be cos x. So you write cos, what was there instead of x, you write x square there. Now we don't have x there, whatever it is you write, but whatever you have assumed in place of x, you have to do the derivative again. So there was no x right here, there was x square, so I have to take the derivative of that and multiply. So that is the chain rule. I'll explain uh, in one more way. I'll explain one more question. Suppose you have a cos of x power 10, okay, y equals to. Now the derivative is, what is the derivative of cos x? If there was cos x here, what would you write? You would write minus sign. So here I'll write minus of sine of, in place of x, x power 10 we have, so whatever it is I'm writing. But now there was something else in place of x, so I have to take the derivative of that and multiply. So there was x power 10 in place of x, right? So I'll write 10 into x power 9, because derivative of x power 10 is x power 9. So your answer is minus 10 x power 9 into sine of x power 10. So this is chain rule, correct? I'll do one more problem. I'll do one more problem. If y is equal to, say, e power x power 100, so what is dy by dx? What is dy by dx? So e power x is e power x, but in place of x you have x power 100, so I am writing it as it is. Okay, but there is something else in place of x, so I have to take the derivative of that and multiply. So it is 100 into x power 99, n into x power n minus 1. So what is dy by dx? 100 x power 99 into e power x power 100. I'll do one more example. If y is equal to a sine omega t, omega t. Now here instead of x it is a function of t. So I'll, instead of asking dy by dx, I'll ask dy by dt. So dy by dt is what? A is a constant, so constants come out while you are doing derivatives, because even if there is constant in our fundamental formula, f of x plus dx minus f of x by dx, if there is a constant, that constant can come out and just stay. So constant will come out. What is the derivative of sine omega t? It is cos omega t. Sin t is cos t, so sin omega t is also cos omega t. But in place of t, you don't, in place of t, you have omega t here. Okay, so I have to take the derivative of omega t and multiply. What is the derivative of omega t? So omega into t. So derivative of x is 1 with respect to x. So derivative of t is also 1 with respect to t. So here you will have omega. Okay, so what do you have? A omega cos omega t. Okay, so dy by dt is a omega cos omega t. Correct? I'll do last uh, problem based on chain rule. So suppose you have y equals to, last time we did sine of x squared, right? This time I am doing sine square x. Sine of x square is different and sine square x is different. So what is sine square x? Actually, sine square x is another way of writing sine of x whole squared. Now what do you do to find dy by dx? So here in place of x you have sine x. So if it was just x squared, you would have written 2x. But here you have sine of x whole squared. So instead of 2x, you will write 2 into sine x. You will write 2 into sine x. Now by chain rule, what do you do in place of x? See, this was x squared, you would have written 2x, right? But in place of x, you have sine x. So you have written 2 into whatever was there in place of x. In this case, it was sine x into derivative of whatever thing you assume in place of x. It is sine x, so it is derivative of sine x is cos x. So dy by dx is 2 sine x cos x, correct? Which is nothing but sine 2x, because we saw this identity already with this relationship already. So dy by dx is sine 2x. So if y is equal to sine square x, by chain rule, what did we get? Dy by dx is equal to, we got sine 2x. There is another way of doing this. There is another way of doing this. See, there is another way of doing this. If y is equal to sine square x, I can rewrite it as 1 minus cos 2x by 2, right? This identity we learned already. Y is equal to 1 minus cos 2x by 2. So what is y equals to? 1 by 2 minus 1 by 2 into cos 2x, correct? So what do you get here? Y equals to, sorry, what do you get here? Now let me do dy by dx. Dy by dx of 1 by 2 is what? 0, because constant has derivative 0, minus 1 by 2 is a constant which is multiplied to this, so I am writing as it is. So what is the derivative of cos 2x? It is, what is the derivative of cos x? It is minus sin x. So cos 2x is also minus sin 2x, but in place of x there was 2x, right? So I have to multiply the derivative of it. What is the derivative of 2x? It is 2. 2 into derivative of x, which is what? 1. So it is 2 into 1, 2. So what do you get here? This minus minus will become plus. This 2 and this 2 will cancel. What will remain? Sin 2x. So either way, if you do it like this or like this, you will get sin 2x. Here what did I do? I directly applied the chain rule. Okay. So sine of x whole square was 2 sine x. But in place of sin x, we have sine x. So I have taken, I have to take the derivative of sine x and multiply. So it is cos x, and I multiplied it. Okay, I got it. So again, at the end, I got 2 sin x cos x, but 2 sin x cos x is sin 2x. So I got sin 2x here, correct? Now, here what did I do? Instead of taking the derivative as it is, first I use the identity 1 minus cos 2x by 2. So it got splitted into 1 by 2 minus half cos 2x. So when I did the derivative, I had two terms here. First one was constant, so derivative of constant was 0, and then half I wrote as it is because it is a constant. And what was the derivative of cos 2x? It was sin 2x minus sin 2x. Cos x was minus sin x, so cos 2x is minus sin 2x. But in place of x, you have 2x, so I have taken the derivative of 2x and multiplied again by chain rule. So I got this. Again, I got sin 2x. Here sin 2x and here sin 2x. Either way, you will get sin 2x. So this is your chain rule. This is your chain rule. Okay. Next, there is last rule, which is called product rule. So product rule, we'll see product rule. So product rule says what? If you have any two functions, if f of x is a product of two functions, u of x and v of x, then dy by dx or f dash of x is equal to u of x into v dash of x plus v of x into u dash of x. So this is the chain rule, or in other words, If in other words, how to write this? If y is equal to u into v, then dy by dx is equal to u into dv by dx plus v into du by dx. Okay, this is the product rule. So I'll first show an example and then prove it why this is true. So the example is this. If you have any function like f of x equals to x square into sine x. Okay, so you have two functions here, x square and sine x. So what is dy by dx? Dy by dx is, so the thing is this. See, first you keep x square as it is and you multiply it with the derivative of sine x. Okay, so here you put u as it is and then you multiply by derivative of the second function, plus you put the second function as it is and you multiply it with the derivative of first function. Okay, so according to that I'm putting x square as it is, derivative of sin x is cos x, plus I'm putting second function as it is and I'm multiplying it with the derivative of first function. So this is your derivative. Clear? I'll write one more. I'll write one more example. If y is equal to e power of x into cos x. So here also you have two functions, correct? So what will you do here? What is dy by dx? Dy by dx is equal to, I'll put e power x as it is and multiply it with derivative of cos x, which is minus sin x. Plus, I'll put cos x as it is and multiply with derivative of e power x, which is again e power x. So it is e power x common if you take cos x minus sin x. So this is your product rule. Now why is product rule working? Let us just prove it quickly and then we'll proceed to new formula. So what is product rule? Product rule is, if y is equal to u into v, then dy by dx is equal to u into dv by dx plus v into du by dx. Correct? So the proof is this. Proof is simple. So you know the fundamental, see, f of x plus dx minus f of x by dx is equal to f dash of x or dy by dx if y is equal to f of x. Correct? So this is the fundamental rule. This is the fundamental rule. Now here we have f of x is equal to, what do we have? F of x is equal to, we have f of x equals to u into v. So this f of x will become what? v into x plus dx into u into x plus dx minus v of x into u of x by dx. Correct? Now if I add and subtract f of, so let it be as it is, v of uh, yeah, v of x plus dx into u of x plus dx. If I subtract this, okay, I'll subtract in green. If I subtract v of x plus dx into u of x here, what should I do? I have to add it, right? Because I cannot just subtract it. So v of x plus dx into u of x. That means I have subtracted and added this intentionally. Minus v of x into u of x remains. V of x remains here. Whole thing divided by dx. Correct? Now, why did I add and subtract? You will understand now. Watch carefully. So here, if I take v of x plus dx common among these two, what will remain? U of x plus dx minus u of x. So this and this minus u of x. Correct? So here what you can take common in these two? You can take u of x common. So plus u of x common if I take from here and here, what will I get? V of x plus dx minus V of x by dx, correct? So overall what you get is, see, this V of x plus dx is almost V of x because dx is small, into u of x plus dx minus u of x by dx, okay, plus here if you take u of x, what will remain? V of x plus dx minus V of x by dx here again, correct? So overall you got this. What did you get? So here it is V of x, and by formula of fundamental theorem of calculus, this is u dash of x plus u of x into v dash of x, correct? Basically it is nothing but v of x into, or if you rewrite it like this, it is v into du by dx plus u into dv by dx. Okay, so what was the question? Question was this: if f is equal to u into, sorry, if y was a product of two functions, u of x and v of x, u into v, then dy by dx by product rule is u into dv by dx plus v into du by dx. That proof we did just now. Clear? So I will use this product rule, chain rule, and derive new functions in the next class. I will derive new functions in the next class. So in the next class, I will give you all the derivatives, and then we will proceed to the DPPs, which have problems related to derivatives. Okay, and then we will go to integration. So now I am ending the stream. In the next class, we will discuss rest of the derivatives using these two rules, chain rule as well as product rule, and then we will solve the DPPs in which we have problems based on derivatives, and then I will tell you what derivatives are in physics. That means this derivative of displacement is velocity, derivative of velocity is acceleration, so on and so forth, how they are related and how graphs make sense and how to look at the graphs and uh, you know uh, make conclusions from the graphs. All those things we will see in the next class. So these classes are taking little bit time, but I don't want to make you just memorize the formulas without understanding and deriving them, because the depth with which you apply the concepts after derivation will be much more, uh, compared to the situation where you just memorize the formulas and apply in the later chapters. So just have patience. If you didn't follow this lecture properly, you can just rewatch it from the YouTube. I'll upload it, but just make sure that you understand and follow each and everything that I taught in the class. Now I'm ending the stream. We'll start the next stream after some time, maybe the chemistry class. So physics class will be later. Okay, I'll just announce it before taking. So thank you. Thanks for watching.